Hey, 8th grade. So our learning target today is I can find the point of intersection or the POI between two equations using a table and a graph. So POI, point of intersections, when will the two lines be exactly the same? Very important piece of what we do in 8th grade. So we're going to talk about just how do we find it in a table and a graph. So for in a table, we have to find the point where the x and y are the same. That sometimes takes us some time to figure out. Um, Sometimes it doesn't just happen right away in the data values. So we'll talk about what to do then in that case today. So we're looking for where the x, y's are the same. How do we do it when it's a graph? Graphs are super easy. Graphs are just where the two lines cross each other. So that is pretty easy for us to see. So we're going to start with this table. Looking for the POI. We don't really know where the POI is going to be. So what I recommend, first of all, is make sure that you're in y equals form. We are in y equals form here. This graph is the equation's a little bit backwards than what you're used to, so I might rewrite it. I might flip it using some properties that we know, commutative property, to switch some things around. Maybe you're a little more comfortable with this form, y equals 2x. We can flip it due to the commutative property. So we have x and we have y. We're looking for the point of intersection between these two lines. Now we don't know where they're going to intersect, so what we usually recommend as math teachers is pick a couple negatives, -2, -1, pick 0, and pick a couple positives. Dilemma is they might not intersect within these 5 points, but that's a good starting point. Kind of check to see, are they close in the negative world? Are they close at 0? Or are they close in the positive world? So now we're going to go ahead and plug in the x values to each of these. We're going to take the -2 and we're going to substitute in for x. So that's going to be 2 times -2. So I'm plugging in right here, is -4. You can use your calculator if you need to. Then we have 2 times, and we're going to plug in a -1 here, is -2. Again, feel free to use your calculator if you need to. Plugging again. So we have y equals mx plus b, but there's the plus b is gone here. We plug in 0, which is 0. We plug in 1. 2 times 1 is 2. We plug in 2, so we have 2 times 2, which is equal to 4. So you might need a calculator, as I said, or they're all triangle problems down here. So no, we're not sure if the intersection is going to happen within these points. We might have to add more to our table. That might happen in your work today, in your homework as well. So we're going to just kind of see what happens. So as I start to solve them, we have to plug in as well over here. I'm going to stop, chop this. Some of you might be just using your calculator to plug in. I'm going to show my work over here, and I probably will have to end up erasing it. But we have 4 multiplied by, I'm going to put the -2 in here, -2 plus -2. Again, I'm going to have to erase my work because I'm writing over my graph. 4 times -2 is -8. -8 plus -2 is -10. Plug in -1. So we have 4 times -1 plus -2. 4 times -1 is -4 plus -2 gives us -6. Again, use your calculator if you need to. Plugging in zeros, we're going to plug 0 in. That's 4 times 0 plus -2. So I'm plugging in 0 in here. That's 0 plus -2. Now you might notice a pattern over here that's happening. I'm actually going to come back and erase these because it's getting quite sloppy over here. As I keep solving, guys, we're going to keep plugging in. We're going to plug in a 1. Some of you can do that one in your head. 4 times 1 plus -2. That's 4 plus -2 is 2. Again, use your calculator if you can't keep up at this pace, or pause the video if you can't keep up with me. Multiply by 2. We go 4 times 2 plus -2 gives us 8 plus -2. $8 in the bank, take 2 out, gives us 6. You'll notice a pattern is happening over here. It's changing by your slope, as it should. Now we know how to fast graph that. Whoops, I just erased the data point we needed. We can fast graph that, or we can plot points. I think I'll plot points this time instead of fast graphing. Looking for a point of intersection. In the table, we see it. You should see it. Is there a point that's the same in the table on the left as the table on the right? 1, 2 is the same in both. So our POI in the table is 1, 2. It should be the same in the graph, but we'll just go ahead and make sure. So we go to graph it. So as I go to graph it, I go left 2. I'm going to plot this point right here. Elevator analogy, find the elevator. It's at left 2, and then go down 4 floors. Left 2, down 1, 2, 3, 4. Elevator analogy, left 1, down 2 floors. Left 1, down 2. Elevators at 0, 0. Elevator right 1, up 2. Right 1, up 2. Elevator right 2, up 4. Right 2, up 1, 2, 3, 4. So here's our line there, y equals mx plus b. And there's our line, y equals mx plus b. We have y equals 2x. Y equals 2x. kind of a fast graph of that. This data point over here is at negative 210. Elevator's at negative 2, and we're going to go down 10 floors. So we're going to go left 1, 2, down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Elevators at negative 1, go down 6 floors. Left 1, down 1, 2, 3, 4, 5, 6. Elevators at 0, go down 2 floors. Elevators at 1, go up 2 floors. Oop, there's our POI. That's what we're looking for. That's what we're hoping for. Elevators at 2, up 6 floors. Right, 2 up. 1, 2, 3, 4, 5, 6. So there is our line. Looking for our point of intersection. Our point of intersection is right here. At 1, 2, there's our POI. So you can see it happened in the table and it happened in a graph. There's our point of intersection. So a couple things to look at. The point of intersection is where two equations have the exact same xy value. You can see it in a table. You're looking for where does it intersect in the table. When is it the same in the table? And you can see it in a graph. Easiest way to find a POI is by graphing first. So if you graph first, then you can pull back to the table. I did it in opposite order, but I just wanted to show you that you can get it from a table. But sometimes if you graph it first and you find it, let's say it's at, in this problem 3, 2, then you can pull it right back to the table and it's much faster, okay? So that's what our work is today, is setting up tables and graphs. You might want to graph them all first and then pull back to the table, just a little strategy of getting to it faster so you don't have to guess forever. Sometimes it's not going to show up right away in your table. You might have to extend a little bit. You might have to extend some of your data points off the graph, kind of guess where they are if the graphs are too small. You need to get all the way through page 14 for homework tonight. So again, homework is through page 14. You might have to extend your tables and graphs. You might want to graph them first. Go ahead and try that. I did not show you that in our classwork today, but you might want to do that. Homework through page 14. Have a fabulous night, 8th grade.